Hi, my name is Katharine Hayhoe. I'm a climate scientist. I study this amazing planet that we live on. I study all of the natural ways that it changes every day, but I also study the long-term changes that can be both natural and, as we see today, because of humans. How could we humans affect something as big as our planet, though? I mean, we're just these tiny little people running around. We don't even look like ants from space. You can't even see us. If you were an astronaut up in the International Space Station and you looked down at Earth and you took a picture during the day, this is what it would look like. This pristine, untouched globe where you can't see a single trace of human civilization. But today, there's a lot of people in the world. Over the last few hundred years, human population has grown exponentially. Today, we have almost 7.5 billion people on this planet. And so today, I think a more accurate way to look at our planet is not as if we were taking a picture of it during the daytime, but rather as if we were taking a picture of it at night. This is a real composite image of the Earth. Again, if you were an astronaut up in the International Space Station, this is what you would see if you looked out the window at night. There's so many of us living on this planet that every acre of land that's good to build a city on, we've built a city. Every acre of land that's good to grow crops on, we're growing crops on those. And every drop of water that we have, that people need for their homes, that people need for industry, that people need for farms, every drop of water we have is allocated. And this is a joke from California, sort of a dark joke, about how farmers this season during a drought, we're getting literally drops of water because there isn't enough to go around. The idea that we have 7.5 billion people on this planet that all need air to breathe, water to drink, food to eat, places to live, has led to the idea of planetary boundaries. The concept that in different areas, including how we use our land, the integrity of the biosphere, that's all living things on this planet, our changing climate, and other issues like the ozone hole. In terms of all of these issues, we have finite boundaries on what we can do on this planet because there's only so much space to go around, only so many resources to go around, and there's a lot of us. So there's these websites you can go to where you can enter where you live and what your lifestyle looks like, and they will calculate how many planets we would need if we all lived the way our family does. So if everybody on the planet, all 7.5 billion of us, lived the way your family does, here's how many planets we would need. I did this myself because I was kind of curious, and this is what I found. If everybody lived the same type of life as me, we would need 5 planets to support all of us. Not only that, but we would need 23 acres of land per person to live on and to grow all our food. And the reality is that we have more like about 1 acre of land per person that we can actually grow food on here on this planet. So is the problem that we have too many people? No, that actually isn't the problem. The problem is that a very few number of people are using disproportionately more resources than the rest of us. And that puts us at risk. We're at risk because we don't have enough to go around between us humans as well as between us and the natural environment. And that's really not fair. We're at risk though today because of something else, not just the fact that we're using all of these resources in a very unsustainable and unfair way, but the fact that things are also changing. What am I talking about? I'm talking about the fact that, from day to day and from year to year, we expect our conditions to be hotter and colder or wetter and drier. But our human society is built on an assumption that we don't often think about very much. That is the assumption that over long periods of time, climate timescales, the average of at least 20 to 30 years, it all averages out. What type of assumptions are built on this? All kinds of assumptions. Where we build our cities, where we grow our crops, how much water, energy we're going to need. What happens if that assumption is no longer valid? What happens if we still have, heat and cold and wet and dry, but what happens if our long-term climate is changing? What's at risk? The way we build our homes, how big of an air conditioner we need or a heater, how much it's going to cost us each month in bills, where our flood zones are, what are our risks of being flooded, what types of crops we can grow in the places that we live, how much water we're going to have in the future. All of these things assume a stable climate. They assume that by looking backwards 30 or 50 or even 100 years, we can predict what's going to happen in the future. This puts us at risk because not only do we not have enough to go around, but the risks that we already face today are being exacerbated by a changing climate. Here's the question though. Is climate really changing? How do we know? Let's look at this question first. Between the months of about November and April, this is the number one question that I get. It's freezing outside. Where's global warming now? We're not talking about a change in weather though. Weather is like a single tree. It's what happens in a certain place at a certain time. It's that record cold or hot day, or even that record cold or hot week. But that doesn't really tell us much about the long-term trend. To look at the long-term trend in climate, we have to add up weather observations over at least 20 to 30 years in all kinds of different places around the world to say, hey, are things really changing? And when we do that, we see that just because one place might say, oh, it's cold outside, global warming can't be real, doesn't mean that climate isn't changing. In fact, it's kind of like as if you were on the Titanic and you said, hey, the ship can't be sinking because my end just went 200 feet up in the air. We have to look at the big picture to see if climate is changing. And when we look around the whole world and we add up the temperature recorded by over 10,000 thermometers around the whole planet, this is what we see. This is our global average temperature. But hang on, you might say, that doesn't really look like it's going up, does it? And it's true. If you look at a website or a news site or somebody even on TV, you'll hear people all the time saying, oh, that global warming thing stopped. It's not getting any warmer anymore. Why are they saying that? It's because they're looking at very short periods of time. And as you just learned, what is climate? Climate is the average temperature over at least 20 to 30 years. So what does this graph look like if we add in all the other data for the other years? It looks like this. The reality is that climate is changing. One year might be cooler, one year might be warmer. In recent years, we've broken a lot of records, and 2016 was the warmest year on record, but next year probably won't be. Does that mean that the planet isn't warming? No. Over climate timescales, our planet is warming. Now, some people might say, yeah, but those thermometers, can you really trust them? Well, the thermometers have been checked very carefully by hundreds of scientists for decades to account for factors like the fact that our cities are expanding and our land surface is changing, and these affect the temperatures that are measured by thermometers. But here's the thing. To find evidence that the planet is warming, we can throw out the thermometers. Throw out every single one of them. Throw out the satellite records. Throw out the ocean buoys. Throw out every scientific measurement that people use to show that the planet is warming. You know why? Because to see that it is getting warmer, all we have to do is look around our world. If we look up in the Arctic, we see that there's over 200 Native American villages built on land that used to be permanently frozen all year round. Today, because the Arctic is warming so quickly, that land is thawing and crumbling and people's homes are falling into the ocean. In Japan, they have kept records of when the cherry blossoms flowered for over 1,100 years. In Washington, D.C., they've been keeping those records for 100 years. And we see that whether you look in Washington, D.C., or whether you look in Kyoto, Japan, cherry trees are blooming much earlier in the year than they ever have. Why? Because it's getting warmer. We can look also all around the world at how heavy rainfall is increasing. How is this an indicator of a warming world? Well, because when it gets warmer, evaporation speeds up. So the warmer it is, the more water evaporates out of our lakes and rivers and streams, and especially out of the ocean. All of that water is sitting up there waiting for a storm to come along, and when a storm comes along and picks it up, it dumps it on us, and we're seeing that our heavy rainfall events are increasing. If you live in the Gulf of Mexico, you know that hurricanes are just part of life. Hurricanes are not getting more frequent, but they are getting stronger. Why? Because they get their energy from warm ocean water. And as the ocean and the atmosphere heat up, they're powering stronger hurricanes. If we look around the entire planet, there are over 26,500 natural thermometers telling us that yes, it is getting warmer. The next question then is why? Because we know that climate has changed in the past, right? We know that there have been periods when it's been warmer and it's been cooler. If you've watched Jurassic Park or the Ice Age movies, you know that the world used to look very different. So how do we know that it isn't just a natural cycle or the sun causing our current warming like it's always been in the past? Let's look at both of these to see if they can explain our current warming. So first of all, with the sun. This is the average temperature of the Earth over the last 100 years or so. The squiggly line is every year, and then the thick line is the long-term trend. And again, it goes up and down from year to year, but over climate timescales, it is definitely warming. So if our temperature were being controlled by the sun right now, if the sun were the number one reason why temperature was getting warmer, what do you think would be happening to the sun's energy? It would have to be going up, right? Imagine you're standing in front of a lamp and the lamp has a dimmer switch. You'd have to turn that dimmer switch up, make the lamp brighter to get more light and more heat, right? In the same way, sometimes the sun gets a bit brighter, sometimes it gets a little bit dimmer. That's just natural. And if we look at the sun's energy over the last 100 years, it actually was going up. It was going up a little bit, not too much, but some, till about the 1970s. But since the 1970s, it's been going down while the temperature of the Earth has been going up. So it can't be the sun that's causing our current warming. What about the Ice Age cycles? Well, the Ice Age cycles do cause us to get warmer and cooler. And we know that we had an Ice Age a while ago where half of North America was covered in almost a mile of ice. So it's a natural question to say, couldn't we just be getting warmer after the last Ice Age? But when we look at our natural thermometers from ice cores and from tree rings, we see that actually our warming after the last Ice Age peaked about 6,000 years ago. And since then, our temperature was in a long, slow slide into the next Ice Age. That's right, according to our geologic calendar, the next thing on our calendar was another Ice Age. Was, that is, until something strange started to happen about 300 years ago. It didn't just look strange in terms of the temperature record, it also looks quite strange in terms of the carbon dioxide record. It was nice and stable, and then all of a sudden, about 300 years ago, started to go up very quickly. So this gives us a huge clue. There's something going on with temperature and there's something going on with carbon dioxide, but it can't be the natural cycles that bring the ice ages, because according to those, we should be getting cooler, not warmer. So the sun has an alibi. Natural cycles have an alibi. Now we have to look somewhere else to try to explain why this planet is warming. And to look for an explanation, we're going to go back to this picture of the world at night. Most of what you see on this picture are cities and roads, right? But there's something up there in North Dakota, and I've put an orange square around it, so if you're geographically challenged, you can see where North Dakota is. There's something up there in North Dakota that is not a city. What is it? Those are the lights of thousands of flares from fracking wells. And this is where the story of energy begins. because we're talking about the world's resources, right? And about how a few of us use many more of those resources than others. One of those resources is energy. Again, we have almost 7.5 billion people in the world. Why did we grow so quickly over the last 300 or 400 years? It's because the quality of our life changed dramatically when we figured out how to dig massive amounts of coal and gas and oil out of the ground and burn it. Coal and gas and oil powered the Industrial Revolution. And the Industrial Revolution brought all kinds of benefits to us that have lengthened our life and improved the quality of our life. What types of benefits did the Industrial Revolution bring? Refrigeration. Imagine if you couldn't refrigerate your food. It would be going bad all the time. Electricity. Imagine if you didn't have any lights in your house and you had to rely on oil lamps or candles or nothing. Transportation. Imagine if the only way you could get from point A to point B was on a horse, if you were rich enough to own a horse. If you weren't, your legs. And medical advances. With all of these other benefits came incredible medical advances. We now live much longer and much healthier lives than we did 200, 300, 500 years ago. So the Industrial Revolution brought all kinds of benefits. But at the same time, there's still 1 billion people around the world who are living in energy poverty. Energy poverty is very real. And so we may say logically, well then clearly to help developing countries, they need coal and oil and gas just like we used for the last 300 years. Here's the problem though. When we look around the world at coal or oil or gas, what countries, what continents have it? North America, Europe, Northern Asia, Australia. Not really much in Central and South America, not really much in Africa, not that much in Southeast Asia either. In fact, if you look at how much remaining coal and gas and oil reserves different continents have around the world, 37% is in North America, 20% in Europe, 20% in the Middle East, 14% in Latin America, much of that in Venezuela, and Africa and the Pacific Asian states have hardly anything. We aren't going to be able to fix energy poverty by just saying, hey, you guys can use just as much coal and oil and gas as we have, because they don't have it. Not only that, but we've just been talking about a changing climate. And there is a direct connection between burning fossil fuels and the warming that we have seen. It isn't the sun. It isn't a natural cycle. For the first time in the history of this planet, it really is us. Why do we care about carbon dioxide? We produce a lot of it. We've been keeping good records of how much coal and gas and oil we've burned over the years, and so we know how much carbon dioxide we've produced. Why does it matter to us, though, and how could it possibly be tied to a changing climate? We know that the Earth has this amazing natural blanket of heat-trapping gases. The sun's energy shines down and goes almost all the way through this blanket like a window. But then the Earth heats up and gives off heat energy. And just like a blanket traps your body heat on a cold night, this natural blanket of heat-trapping gases traps the Earth's heat, keeping our planet almost 60 degrees Fahrenheit warmer than it would be otherwise, or 30 degrees Celsius warmer. This is why we have life on Earth. Without this natural blanket, we'd be a frozen ball of ice. If this is natural, then what's the problem? By digging up massive amounts of coal and gas and oil, we are wrapping an extra blanket around the Earth that it didn't need. And just like my grandma used to do when I was little, she would sneak into my room when I was asleep and put an extra blanket on me, and I'd wake up sweating saying, "Grandma, I didn't need this extra blanket." In the same way, we're wrapping an extra blanket around our planet that it does not need. It's trapping too much heat, and it's heating up. How long have we known that burning coal and gas and oil is wrapping an extra blanket around our planet? Well, since the days of Joseph Fourier in the early 1800s, we've known that our planet had a natural blanket. Since John Tyndall in the 1850s, we knew that burning coal and gas and oil was wrapping an extra blanket around our planet that it didn't need. We've known that for over 160 years. Arrhenius was a Swedish chemist who won the Nobel Prize for chemistry, and in his spare time, he calculated how much the world would warm if we doubled or tripled the levels of carbon dioxide in the atmosphere. His numbers were right on par for the numbers that we know to be true today, 125 years later. Guy Callender published a paper in 1938 showing that he had already measured the warming of the planet using hundreds of thermometers from all around the Earth in response to burning fossil fuels. And Charles Keeling set up an observatory on Mauna Loa in Hawaii to actually track levels of carbon dioxide in the atmosphere and show that, yes, they are increasing. This is not a new science. We have known this for a really long time. But the next question we have to ask is, why do we care about this? Because if you pick up a book about global warming, or if you go to see a movie about global warming, there's going to be one picture, more often than not, on the cover of that book or on that movie poster. That picture is going to have something on it that is white and very big and furry, and probably sitting on a melting piece of ice looking very sad. Yes, I'm talking about a polar bear. Now, don't get me wrong, polar bears are one of the first species to be directly endangered by a changing climate. That's why they're the poster child of climate change. Polar bears only eat when they're out on the ice. And the ice is coming in later and later in the year and leaving earlier and earlier, leaving the polar bears stranded on land for months with no food. The reality, though, is that after the polar bear, we're next. What do I mean by that? Well, remember how I talked about how every acre of land where we can build a good city already has a city built on it? Did you know that 2/3 of those cities are within a few feet of sea level? That's right, 2/3 of the world's biggest cities are on coastlines within a few feet of sea level. And sea level is rising. Why? Because warmer water takes up more space, as well as the fact that land-based ice is also melting, like the ice sheets on Greenland and Antarctica, and all of that water is going into the ocean. Our cities are at risk, and you can't pick up 2/3 of the world's biggest cities and just move them. I talked about how every acre of arable land is allocated. What happens if you can't grow cotton where I live in Texas? You can't just move up to Kansas and say, oh, well, I want this land. No, because somebody else already owns that land. We can't pick up all our farms and move them if climate shifts and we can't grow our crops there anymore. And what about water? We already don't have enough to go around. And the warmer it gets, the faster our evaporation rates get. That means that water will evaporate out of our soils and our reservoirs faster in a warmer world. It might come back down in heavy downpours, but there'll be longer dry periods in between in many parts of the world. We already see that the risk of heavy rainfall events is increasing, whether we live in North America, where we see this highway flooded, or whether we live in Southeast Asia, where you can see people walking along a flooded road. We also know that as evaporation rates speed up, our droughts are getting stronger and longer. We may just have a drought naturally, as we always have, but in a warmer world, that natural drought will be stronger, and it will often last longer than it would have otherwise, whether it's in Texas, as you can see on the left, or in Syria on the right. Why else do we care about a changing climate? We care about it because of thawing permafrost up in the Arctic, or stronger hurricanes along the Gulf Coast. We care about it because of stronger heat waves in Australia or India that have huge impacts on our health, on our air quality, on our energy systems. We care about a changing climate because it exacerbates so many of the risks we already face today. Taking care of our environment is often likened to the idea of stewardship. We're in charge of, say, a piece of land like a farm, And we know that investing in that farm, planting crops, taking care of the soil, making sure everything on that farm is healthy and productive is a smart thing to do. It's not smart to treat your farm like this, to just extract every penny you can and leave it in rack and ruin. And so we can extend this metaphor, this image, to our planet. We humans, all 7.5 billion of us, this is our home. It just makes sense to take good care of our home because this is the only one that we have, and we don't want a home that looks like this. But there's more to it than that. We aren't all equally affected in the same way by a changing climate. If we look at a map of who is the most vulnerable to a changing climate, it's the people who live in places where they already have energy poverty, as we talked about before. They already have issues with hunger and famine, lack of access to clean water, all kinds of diseases that nobody should be dying of in 2017. It's not fair. The people who are being impacted by a changing climate are the people who are already poor and already vulnerable. We care about a changing climate not just because it exacerbates the risks that we face in the places where we live, but because it affects poor people all around the world. And that just isn't fair because they're the ones who've used less of the resources that have put us in this place in the first place. 1 billion of them don't even have electricity. They've never burned a piece of coal or a container of natural gas in their life. Yet they are most impacted by a changing climate because of all of the extra blanket that we've been wrapping around our planet over the past few hundred years. Why do we care about a changing climate? Because trying to fix issues like malaria, poverty, injustice, lack of access to clean water, all kinds of issues. It's like pouring all of our money and our effort into a bucket, and that bucket has a hole in the bottom. That hole is climate change, and that hole is getting bigger and bigger. We can't fix these global issues if we leave climate change out of the picture, because it is increasing the strength of the coastal storms we see. It's causing coastal flooding. It's increasing the risk of extreme heat waves and droughts and heavy rainfall events and floods in different parts of the world. We care about climate change because it affects our access to food. We care about it because it affects our access to clean water. We care about it because it's affecting the range of all kinds of diseases. We care about climate change because it affects all of us living here on this planet, humans and the natural environment. So, how do we respond to this global issue? As the President's Science Advisor, John Holdren, said, we basically have 3 choices. We can reduce our carbon emissions, that's called mitigation. We can adapt or prepare for a very different future than we've seen in the past, adaptation, and we can suffer. We're going to do some of each. The question is just what the mix is going to be. Now you may say, but hang on a second, this blanket that we're wrapping around the planet, it comes from everything. We're contributing to it every time we turn the lights on, every time we get in our car, anytime we eat meat, because growing meat produces a lot of these heat-trapping gases too. So you might say, is it too late? Is there anything we can do? It's not too late, and there is a lot we can do. And so that's the last question I'm going to talk about. What can we do about this problem? Here's a few ideas. One of the first things we can do is we can acknowledge that this is real. Whether we're affected by flooding in Texas or in Bangladesh, this is a real problem affecting real people today. It's not a hoax. It's not something that's been made up. It's not something that we don't understand well. We've known this is real for over 150 years. We can acknowledge it's a real problem, and here's what each of us can do about it. We can talk about it. Did you know that 75% of people in the United States hear the people they know talk about global warming maybe never, once a year, or maybe a few times a year at most? Hardly ever. We can talk about it. That is one of the most important things we can do. But in talking about it, don't pull out some scientific fact and start whacking somebody over the head with it. No, we can talk about it from the heart. We can talk about ways that people are being impacted by it. We can also talk about ways that we can help. Go online and measure your carbon footprint. Find out where the carbon is coming from in your life. It's different from all of us depending on how we live. And a good carbon calculator will also tell you things that you can do to reduce your own emissions. I'm going to give you some examples. They might sound small and they might sound silly, but they're real. Did you know that if we replace a conventional, regular, incandescent light bulb with a new LED, so I'm not talking about those twisty bulbs, I'm talking about LEDs, you can get them at Walmart or Home Depot. They just cost a few dollars nowadays. They used to be like $20 a few years ago. Now they're just a few dollars. If you switch out your light bulb, you will save anywhere between $40 to $135 in energy bills per bulb. And they last way longer, so you won't have to change them. If everybody in the whole US switched to LEDs, we'd save $250 billion in energy costs. That's a lot of money. If every home replaced only one light bulb, the energy saved would light more than 3 million homes and prevent the carbon emissions of nearly 800,000 cars. That's a lot. What other small, sensible steps can we make? Eating lower in the food chain helps too, because growing meat takes a lot more energy than growing vegetables, and animals, especially cows, and also some sheep and some pigs, produce a lot of methane, which is also a heat-trapping gas. So eating lower down the food chain also helps. I have a series of little videos called Global Weirding. Each video is only about 6 or 7 minutes long, and they all address a question. This question was, I'm just one person, what can I do? You can find our Global Weirding videos on YouTube or on my Facebook page. Just look for Global Weirding, and you can check out this video. We packed over 50 ideas into just 7 minutes of specific things that we as individuals can do. We can also help other people though. We can help people prepare, and this is a picture of a really cool new technology called a fog net, where they're collecting water vapor from the air for poor villages in Africa that don't have a lot of clean water. We can work to end energy poverty using sources of energy that people actually have. Remember how we talked earlier about how a lot of poor countries in the world don't have coal and gas and oil. But you know what they do have? They have wind and they have sun. We can work to end energy poverty in ways that will last, using energy sources that will never run out on us. And most of all, we can tell people that we care. One of my favorite groups is Citizens Climate Lobby. They have chapters in almost every town across the United States and Canada and even around the world. What I love about them is they will talk to any leader from any political party, from any part of the spectrum, because it doesn't matter how we vote. A thermometer isn't Democrat or Republican. It's warming, and it matters to us because it affects us. So make your voice heard. Whether it's talking to your school, whether it's talking to people in your home, your family, whether it's talking to people at your church or community group you're part of, we can all talk about this so we can all figure out how we can act together. Jane Goodall is one of my favorite scientists. I grew up watching her movies when I was a little girl, and she said something, I think, that is profoundly relevant to this issue of climate change and our planetary boundaries. She said it's only when our clever brain and our human heart work together in harmony that we can achieve our full potential. Thank you.